Yesterday we looked at the law of sines. Today what we're going to do is we're going to look at the law of cosines. And we're not going to take the time to derive it today. I'm just going to show you what it is and then we're going to do some practice. But let me know if you want to show where that comes up with. It's based off of the Pythagorean theorem. So the law of cosines is a squared equals b squared plus c squared minus 2bc times the cosine of a. And so remember, little letters are angles, or excuse me, little letters are sides, and capital letters are angles. The thing about this is we can switch around the letters. Like if this was b squared, then our other two sides go on this side, a squared plus c squared minus 2ac times the cosine of b. And if this was c squared, then our other two sides, b squared plus a squared minus 2b times a times the cosine of c. The important thing to notice here, if you have side A here, it's angle A. Side B, angle B. Side C, angle C. And so we're going to kind of use this and we're going to see, when do you use law of sines and law of cosines today? So the first one that we are going to look at, let's say you have a triangle and it is capital T, S and V, and you're asked to find T. So as you can see, we can't use law of sines because we have to have a pair to use law of sines. And we don't have an angle and the side opposite, meaning we don't have capital S and little s, capital T and little t. Oh, this looks bad. That 5, let me see if I can rewrite this 5 so it looks different than the S. There we go. So we're going to use law of cosines. So we want to find side T, so I'm going to say T squared equals, well, our other side, 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of 60. And the nice thing is you can just plug this straight into your calculator. So if you go to Desmos, again, hit that wrench thing. You want to make sure you're in degrees. So we have 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of 60. And we get 21. So we have t squared equals 21. Well, then we know we take the square root to solve for t. So the square root of 21, 4.58. So let's have you guys try one here. So the next one I want you guys to try is, let's say you have 8, 14, and 52 degrees, and you need to find x. So pause the video and try this one. All right, so hopefully you set this up. X squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 52. And then again, you can type this straight in. So we have 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 52. So you have 122.1. So x squared equals 122.1, but then we have to take the square root of it. And we get 11.05. So as you can see, it's pretty easy to use. So now we're going to take a look at another one here. So let's say we have F, G, and H, and we have 3, 5, and 7, and you need to find angle G. So again, we can't use law of sines because we don't have a pair. So what we're going to do is set this up And so if we want to find angle G, I'm going to start with this side and I'm going to set it up 7 squared equals, so 5 squared plus 3 squared minus 2 times 5 times 3 times the cosine of G. Now this one's not quite as easy because you can't just type this into your calculator. You got to follow order of operations. So we have 49, 25 plus 9 minus, well, if we multiply those together, 2 times 5 is 10, times 3 is 30, times the cosine of G. So now order of operations, sometimes we like to put everything on this right side together, but adding, we add those together because multiplying, these are stuck together right there. We can't break that up yet. So 25 plus 9, 35 minus 30, cosine of G. And a lot of people like to jump and say that this is 30, but you'd never do that. Like let's say you were solving an equation, 49 equals 34 minus 30x. You wouldn't say 34 minus 30 is 4x. You'd subtract the 34. So that's what we have to do here. So minus 34. So we have 15 equals negative 30 cosine of G. Divide by negative 30. Well, that's that's 0.5. So negative 0.5 equals the cosine of G. And now we have to do that inverse cosine to find the angle. So functions, cosine inverse. Oh, am I in degrees? Let me check. Yep, still in degrees. So functions, whoops. Functions, the cosine inverse, negative 0.5. And we get 0.99. Doesn't seem quite right. Oh, because I didn't do the inverse cosine. That's right. That didn't look like an angle. So cosine inverse to the negative 1, negative 0.5, and we get 120. So I'm going to put one like this, and I'm going to have you guys try it. So let's say you have 7, 8, and 2, and you're trying to find x. So pause the video and then unpause it once you've tried this. Okay, so hopefully you said, okay, here's x, so I got to start with the one across. So I'm going to have 8 squared equals 7 squared plus 2 squared minus 2 times 7 times 2 times the cosine of x. Then we have to break this up. So 64, 49 plus 4. We can group those together. So that's minus 28 cosine of x. 49 plus 4, 53. All right, so now we're solving. So subtract 53. So we're going to divide by negative 28. So we have the cosine of x equals 11 over negative 28. And now we got to do that inverse cosine of 11 over negative 28. And let's see, make sure I get the inverse this time. So we have 92 degrees. So if I double check that, I didn't think I had the right, negative 11 over 28, so 113 degrees. My bad. So the next thing I'm going to do is we're going to put some triangles and we're going to see if we can decide between, is it law of sines or law of cosines? And we're not going to solve these. We're just going to try the setup. So I'm going to put 4 triangles here. So 17x. And so these are all going to be non-right triangles. And none of them are going to be drawn to scale here. Keep that in mind. We're going to decide which one we're going to use. So again, to use law of sines, we have to have a pair. So if I notice here, I have a pair. So this one I could set up using the law of sines. So I could say the sine of 47 over 17, sine of 38 over x, and we could solve. This next one here, I don't have a pair, so I'd have to use law of cosines. So x squared, 15 squared plus 18 squared, 2 times 15 times 18 times the cosine of 35. But I look at this next one, I have that pair, so that's a law of sines. Sine of 14 over 52, sine of x over 32. And then this last one, I don't have a pair, so that is a law of cosines. So we'd have our 8 squared, 7 squared, plus 6 squared, 2 times 7 times 6 times the cosine of x. And we're not going to solve those, but just to see, you have to have that pair to use law of sines. So the last problem we're going to look at is, let's say we have a triangle. We're going to have a 90 degrees here, and this is x, and this is z, and this is y. I'm going to put a W here. This is going to be 3.7. I'm going to draw a line right here. This is going to be 86 degrees, and right here 71 degrees. And we need to find x. So we can kind of see we have two triangles here. And the nice thing is one is a right triangle. Well, first thing I look at is like, what sides can we find of anything? We don't have a pair so far, but I notice this makes a line. So what's 180 minus 86? Well, this is 94 degrees. Well, now I have 2 out of 3 in a triangle. So what's 180 minus 94 minus 71? See, 86 minus 71, so that's 15 degrees. And I notice now I have a pair. So I could find all sorts of sides to a triangle. Maybe I want to find, I'll call this W. So I could set up a law of sines. The sine of 15 over 3.7, the sine of 94 over W. And we could solve, so W times the sine of 15, 3.7 times the sine of 94. Okay, divide by the sine of 15. So we got 3.7 times the sine of 94 divided by the sine 15. So we have 14.2. Well, that's still not helping us find the other side. But what if we can find, we could call this, oh geez, I don't know. We'll find that little blue X there. So we could set it up, the sine of 3.7. Oops, set that up wrong. The sine of 15 over 3.7 equals the sine of 71 over x. So x times the sine of 15, 3.7 times the sine of 71, divide by the sine of 15. So the same problem here, but we got the sine of 71. So we have 13.5. And now I notice if I take this other one here, this is 13.5, 86. We could use trig to solve this one. So sorry this is getting so messy, but we could say the cosine of 86 equals x over 13.5, and we could solve that. And I think you get x equals 0.9.